All right, let's dive into a story that took an entire century to unfold. We're talking about a tale of cosmic monsters and the faintest whispers of space-time itself.
It all really kicks off back in 1915 with Albert Einstein's game-changing theory of general relativity.
His equations, well, they painted a picture of a universe that was way, way stranger than anyone could have possibly imagined. And that set the stage for two of the biggest, most ambitious quests in the history of science.
So let's tackle that first quest, the hunt for an object so unbelievably dense, so powerful that absolutely nothing, not even light, can escape its pull.
You gotta understand, the idea of a black hole wasn't just accepted overnight. At first, it was seen as this bizarre mathematical quirk. It took decades of fierce debate and some major breakthroughs before anyone took it seriously. It went from a weird solution found in the trenches of World War I all the way to the solid mathematical proofs of the 60s. Every single step was a battle against skepticism.
I love this quote from Oppenheimer. He just perfectly captured the whole idea of an event horizon. That point of no return. Just think about that phrasing for a second. A star collapses so completely that it literally snips itself off from our reality. Wow.
And this is where things get really, really weird. It created this deep paradox where two different people can have two totally different but equally correct experiences of the same event. So to someone watching from a safe distance, you look like you're slowing down and then just freeze at the edge forever. But for you, time would just keep ticking along normally as you slip past that threshold into a place where the only way forward is inward.
And this wasn't some quiet academic disagreement. Oh no. This was a fundamental clash between giants of the field. They were arguing over whether the laws of physics could even allow for something so extreme, a complete breakdown at a singularity. Wheeler, for a long time, argued against them, but Oppenheimer was convinced the math was telling us something deep and unavoidable. Okay, so black holes were one crazy prediction. But here's the thing. Einstein's theory didn't stop there. It also predicted that the very fabric of space-time could ripple and wave, kind of like the surface of a pond.
The best way to think about these is like the sound of the cosmos. They carry information about the most violent, most energetic events in the universe, like, say, two black holes smashing into each other. And as they pass by, they literally stretch and squeeze space itself.
Look, the real goal here wasn't just to put a check mark next to Einstein's name. The vision was so much bigger. For 400 years, ever since Galileo, we've only been able to see the universe. The dream was to finally be able to hear it, to sense the cosmos not with light, but with gravity itself. And that would let us in on secrets that are completely invisible.
But the challenge was just immense. To detect these incredibly faint waves, scientists needed to build an instrument that was 1,000,000 times more sensitive than anything ever built before. That is just an astronomical leap in precision. So how'd they do it? Well, this is the simplified genius behind LIGO, the Laser Interferometer Gravitational Wave Observatory. It's basically the most sensitive measuring device ever made. You shoot a laser, split it, send the two beams down these long tunnels and bounce them back. If a gravitational wave passes through, one arm gets just a tiny bit longer and the other gets a tiny bit shorter. And that minuscule difference is exactly what they're looking for. Think about this for a second. The project was so out there, so audacious, that their strategy was literally to build the first version expecting it to fail. The first LIGO wasn't actually meant to see anything. It was just a full-scale dress rehearsal. It took decades of work, tons of skepticism, and hundreds of scientists dedicating their entire careers to this seemingly impossible task. Okay, so fast forward through 40 years of relentless effort. The new advanced detectors were finally switched on, all set to begin their first official search, the moment of truth.
And then it happens. Before the experiment even officially starts, the automated system flags a detection. And the signal is, well, it's perfect. Too perfect. It was the exact chirp sound they predicted two massive things would make as they spiral into each other, faster and faster right before merging.
The signal was so clean, so textbook perfect, that even Kip Thorne, one of the co-founders of the whole project, was totally convinced it had to be a test, a fake signal secretly put into the system to keep the team on their toes. It just couldn't be real. But here's the twist. It wasn't a test. No one on the team that does the fake signals had sent it. So the team spent the next 6 agonizing weeks trying everything they could to prove it was false.
They checked every single one of their 100,000 data channels for glitches, errors, even hacks. They had to be 100% sure.
They found nothing. Nothing wrong at all. The signal was pristine. And in that moment, everything changed. It was real. Humanity had just heard the universe for the very first time. And in one incredible event, both of Einstein's great quests, the hunt for black holes and for gravitational waves, were finally fulfilled.
But that first detection, that wasn't the end of the story. Not even close. It was the explosive beginning of a whole new field of science. This discovery literally gave us a new sense to explore the cosmos with. It allows us to perceive things that are completely dark, totally invisible to any telescope. It's like, imagine going your whole life only being able to see, and then suddenly you can hear. That's the scale of this.
And the pace of discovery since then has been just astonishing. What started as a rare event every few weeks has turned into a steady flood of data, with new detections happening every single week. We've gone from a once-in-a-lifetime discovery to business as usual, and it's completely transforming what we know about the most extreme parts of our universe.
And you know, we are just getting started. Right now, we're using these waves to test the fundamental laws of black holes, and we're inching closer to the ultimate prize, hearing the echo of the Big Bang itself. The greatest mysteries are still out there, just waiting to be